I'm Devansh and this is my self-driving car. I started off with a rough sketch of the shape of the body, but I quickly changed this after I came across this video. This video inspired my design and really helped me figure out how to make the cardboard body. This is the circuit. I use an Arduino Uno with a stacked L29 motor driver. There are 4 gate motors and two ultrasonic sensors. I removed the LDR sensor, and for power I use 6 AA batteries instead of these 2 9-volt ones. I started off with the chassis. So first I had this acrylic plate and I added a cardboard extension. I also had an Arduino Nano for controlling the LED lights. But I later realized this was way too small and the car would look out of proportion. So I made a new larger chassis out of cardboard. I used Lego wheels here, but I replaced them with the original ones because they were causing some problems. I also added styrofoam for better mounting of the body. To make the body, I used pieces of cardboard and joined them using hot glue. I also used PVA glue in combination with brown paper to give some smooth edges. For the interior, I used a white, brown, and black color palette. There are some seats with some fake cup holders and media controls. Now as you can see here, I cut out the holes for the wheels because when they were covered it was causing some problems, and I shifted the ultrasonic sensor down instead of in the front right. For the finishing touches, as previously mentioned, I used brown paper with PVA glue. This can cover up rough edges and give them a smooth look. Now it's time to give it a paint job. I used red and yellow paint with 2 coats, and that matched perfectly with the wheels. And here is our final product. And I forgot to mention, I also painted the windows black to make it look like tinted windows. Now for the code. I started off with some planning. So here's a flow chart I made. These are all the test cases. I just used this tree to kind of figure out what type of situations it might be in. Now here are some tests of code for the motor driver and for the ultrasonic sensors. And then I went on to develop version 1. So here I had some issues, my car kept headbutting the wall. But I fixed that, and in version 2 I improved in many ways. In version 1 I used a lot of manually controlling the movement of the motors, but in version 2 I used functions and nested if statements. Now let's see it in action. Here's the setup I made in the garage. Now you can see here the robot is kind of getting stuck, and this is where a third ultrasonic sensor on the left hand side would have come in handy. However, the robot manages to maneuver its way out of that position, and it's easily able to avoid any other obstacles. And then it parks itself inside the spot. Now this is it reversing using its 2 ultrasonic sensors. Now the limitations of this project. Well, there was one big one, which was that I only had 2 ultrasonic sensors. It would have been better if I used more ultrasonic sensors for the car to have a better understanding of its surroundings. Now for the improvements. So obviously, as I mentioned earlier, more ultrasonic sensors would have really helped. And these, in combination with infrared sensors, would really help it recognize some obstacles. And as for the body, I think I did a pretty good job, but I think I could have improved on it in the shape. I could also use a compass module so it has a sense of direction and it knows where to go. A GPS module can be used as a locating beacon, as well as to give it GPS coordinates to navigate to. And finally, an accelerometer could be used to know how it's moved. Thanks for watching.